In this video, we're going to look at step functions. Step functions is the next section of Laplace transformations. In this video, we're not going to look at Laplace transformations. We're just going to look at sketching these functions and the unit step and writing in terms of the unit step function. So the unit step function is u of c of t. It's written as 0, 1, 0 when t is less than c, 0, 1 when t is greater than or equal to c. This means you can basically think of step functions as on and off functions, or a switch, if you would. We can assign 0 to be off, 1 to be on. Say this is data from an electric circuit. 0 means the switch is off in the circuit, 1 means the switch is on in the circuit. If the switch is off, it's going to look like this, and it's going to be turned on at time c, and it's on for however long. In this case, for forever. It just tells us what time it's switched. The circuit gets turned on. Basically, that's how I like to think of it. Say we have a situation like this. Well, then it will start at 1. It starts turned on, and then it turns off. So the switch started on, then it turned off at time c. Same thing, just flipped, right? Anyways, I think it's best to just get into some examples here. Well, let me write out this really quick. If you were to do this one, you'd write it as it starts at 1, right? And then you're going down 1, so it would go to 0. You think about it as, how many do I have to jump by? How many do I have to jump to go down to this one? You have to jump down 1. So you think, how do I get to there? How do I go from here to here? I have to go down 1. So it goes to 0. This is from when greater than 1. And this is when t is greater than or equal to c. But less than, greater than or equal to 1. Wait. I'm having a brain fart here. When t is greater than c, yes. Whew. Wait, where am I getting that from? No. This is when t is less than c. Yeah. Okay. Let's look at some examples. I have 8 example problems here. The first 4 just deal with just sketching by themselves. So to sketch this one, I have that down there. But first I'm going to draw or write out this in terms of the unit step function. Right? So it starts, you can think of it as this. G of t is equal to 0 plus u1 of t. See, I just added that 0 there. So in this case, the subintervals are our subintervals. Sub values go with subintervals. Coefficients. Here, I'll just do this. Coefficients go with jumps. So if we start at 0, we're going up 1, up 2, 1 plus 2 is 3. From there we go down 6, so we're going down to negative 3. Okay? Now intervals. 0. That's whenever, so it's when t is greater than 0 or equal to 0, it tells us. And this is when it's, look at the first interval, less than 1. Now let's look at the second interval. So now we're starting at 1. And we're going to 3. And then the next interval, oh, wait a minute. Yeah, that's right. 3, 2, we go to 4. And then after that, it's just goes on forever past 4. Right? So if we were to graph this, 0 from 0 to 1. So 0 to 1, it is 0. Open. From 1 to 3, it is 1. That's closed. From 3 to 4, it is 3. Closed to open. And then it's -3 from 4 and on. Right? That's how you graph that one. Pretty simple. You see it looks like steps, right? It's a step function. They're not all going to look like that, though. They're not all going to be nice like this. You'll see it. The last two are not as nice. Okay, so we have number 2 now. So we have to graph this. So f of t minus pi, u sub pi of t, where f of t is t squared. Think of this as our t. Think of this as our t. In that case, then we plug that in for t over here. That's t squared. So then we're going to have g of t is equal to t minus pi squared times u sub pi of t. So now we can write it like this. So we would start at, remember, there's always that 0 there lurking in the shadows. Whenever there isn't another normal value by itself in this, it always starts at 0. If you have something like this, then it starts at 1. But they'll give that to you. In this case, it starts at 0. So 0, and then we're going up by t minus pi squared. 0, it's greater than or equal to 0, less than or equal to pi, less than pi, not less than or equal to, just less than pi. And then this is greater than or equal to pi. Yep. That's it. Pretty simple. We need to graph this is 0 from 0 to pi. That is not straight, but it's good enough. 0 from 0 to pi. And then it's t minus, so think of t squared, right? T squared goes like this for forever. So something like that. It would just be shifted or whatever, but that minus pi, that's good enough. Yeah, that would be the graph of t minus pi squared. Yes, that would be that is the graph. It's t squared. It's shifted to the right by pi. So yeah, that starts right there. Yeah, we're good. So that would be the graph. This is bothering me. I don't have my arrows there. That's it. Number 3. Same thing. This is our t. We plug that in for t over here. So this is sine of t minus 3 u sub 3 of t. We write it like this now. Once again, start at 0. We go up by sine of t minus 3 greater than or equal to 0. The reason why I'm getting these greater than or equal to 0s is because it tells you for the given function on the interval t is greater than or equal to 0. So you know it has to start at that interval. Less than 3. I got that from this. Sub number goes with sub interval. And then we start with 3, less than or equal to. That's it. So now we're going from 0 to 3, open, and then it's sine of t minus, so sine goes like this. If you plug in 3, t equals 3 into here, that'd be sine of 0, starts at 0, so going like this. Right? That would be that graph. Isn't that amazing? Number 4. Okay, a little bit longer. Once again, we start with 0, right? And then we're going up by t minus 1. And then from there we go down to, so we're going you just add on what's next. So we start with this one, and then we add on the next one. So minus 2t plus 4. That simplifies to negative t plus 3. So then we add that onto the last one. So that's plus t minus 3. Let's rewrite this. 0, t minus 1. This was just negative t plus 3. And those cancel, so that's just 0. Intervals. Less than, start with 1. Start with 1. Go to 2. Start with 2. Go to 3. And then we end with 3. Oh, wait. Start with 3. Okay. From 0 to 1. Sorry for going through these fast. The next few I'll go through slower though. The next 4. 1 to 2, t minus 1. So if we plug in a 1, that is 0. So starts at 0 and has a slope of 1. So that would be closed then. Closed, yeah. Because they connect. They're not separated for this one. They all connect. And then we have minus t minus plus 3. So if we plug in a 2 there, t equals 2, that would start at 1. So it starts here. Slope of negative 1, go down to here. It would be open, but then it gets overlapped with a closed as it goes on forever after that. Right? That's the graph of this one. Number 5. Sketch the graph of the given function and then express f of t in terms of the unit step function. So let's start with part A. Go ahead, try this by yourself. Try and graph by yourself. You could do that with all of these problems. Try and do it by yourself first. Although I didn't explain number B yet, part B yet. There's 2 ways to do part B. Well, I'll get to that. Part A, sketch the graph of the given function. 0 from 0 to 3. Negative 2 from 3 to 5. So closed, open. 2 from 5 to 7, closed, open. Right, those close and opens come from the less than equal to less than. 1 from when it is greater than 7. So like that. That's a straight line. Okay. That's it for the graph. Part B, I copied the problem down here again. Express f of t. I need another page. Because there's 2. I want to show how to do this both ways. I'm going to do every one like that. I'm going to do them both ways. So there's 2 ways to do it. There's the normal way, where you kind of intuitively think about it. And there's also the way, as I said, there's also a systematic way that works every time. Kind of like a little cheat. But the cheat can be a little longer, but it's less thinking involved. Personally, I never knew about this. Okay, well, never mind. Let's just do it both ways. So the first way, we'll do it so 2 ways. So I'll do it. So I'll say 2 ways for B. 2 ways. Here's way number 1. F of t is equal to. So for this first part, you're going to look at what do we have to go down by to get to the next step. So like, what do we have to do to get to the next step? So if we're at 0 here, we have to go down 2 to get to the next step. So we start, well, first of all, where are we starting? We're starting at 0. Always start with where we're starting at. And then we go down 2 to get to the next thing. And then that interval starts at 3, so it's going to be u3. right? And then at the next, and then you look at each thing. You look at 0, you look at 3, you look at 5, you look at 7. So at 3, it was going down 2. At 5, what's the jump here? The jump is from -2 to 2. We're going up 4. So it's plus 4, and that's at 5. Now let's look at the next one. This is probably the easiest way to go about doing this. Let's look at the next one. So we have 7. We're going from 1 to 2. That goes up 1. So then it's plus u of 7. Okay? Now the other way to do this, it's going to be a little bit longer, but it works every time. You can look at just this. You can look at just this for number 2. And what you're going to do is start with 0. So that's 0, 0. And then you go to the -2. So you get -2 u of 3. And then these signs get, and then whenever you do it the second time, you kind of go like this. You kind of like FOIL it. You're going from -2 u3, and then you're going to go over here and you're going to go plus 2 u. Let me think about this. Yeah, I'm good. So you have -2 u3, and you go over here. Then you have, you flip the sign, and you go 2 u5. You go down to this one, you have 2 u5. You flip the sign on the second one, you go -2 u7. And you go down to this one here, and you have 1 u7. So if you add these all up, you'll get -2 u3 plus 4 u5 minus, well, that's not right. That's not right. Oh, it should be minus u7. Where did I mess up? Oh yeah, we're going down 1. My bad. Hopefully someone noticed that. See? You get the same answer both ways. If that was confusing, what I did for that second way was I did 0 to which 0 and 0 is 0, but you start with this -2 then. You go -2 u3, and then you go -2 u5, but you flip the sign on the second side. You go 2 u5, 2 u7, flip the sign on that one, 1 u7, and that's it. So that's another way you can do it. Or you can do it by thinking about it. Oh, we're going to have to go down 2. We're going up 4. We're going down 1. That's probably a lot easier, right? But anyways, number 6. Part A. Let's graph it. 1 from 0 to 1. -1 from 1 to 2. Oh, -1, sorry. 1 from 2 to 3. -1 from 3 to 4. And then 0 from 4 and onwards. So, part B, let's do it both ways. Let's do it way 1, way 2. F of t equals, F of t equals. I need to copy that. Yeah. Or I could just move it down really quick. So, part B. Oh yeah, look at that. I can just, the graph will overlay it, but, all right. We have you can look at the graph or you can look at the chart thing. If you look at the graph, we start at 1. We're going at 0 we have 1. At 1 we're going down 2. At 2 we're going up 2. At 3 we're going down 3. I mean down 2. And then at 4 we're going up 1. Right? So that would be the answer to that one. Let me just check that. 6B. Yes, that's correct. So now if we are to look at, now Formally speaking, you should put the little t's on those, like u1 of t, u2 t. But for simplicity, I'm just gonna write it like this. The other way, if you want to look at this and do it that way, you can look at it like this. We're going from 1 to -1, and you can see you look at the interval in between them, like this. So the 2's, the 3's, the 4, right? You know what I mean? So they both share a 1, so it's at 1. You're going down 2, you're going up 2, you're going down 2, you're going up 1. Right? That's how I think of it. But the second way to do it, we have 1, u0. Okay, so u0 is equal to 1. Just going to put that out there. Okay? So you can do it this way. You have 1, u0, just 1, minus u of 1. We have minus u of 1, signs flipped for the second one, plus u of 2. We have plus u of 2, minus u of 3. We have minus u of 3, and we have plus u of 4. And the 0, that just nothing. So then you'll be left with f of t is equal to 1 minus 2 u1 plus 2 u2 minus 2 u3 plus u4. See how that works? Works every time. Isn't that really cool? I don't know where I learned that from. I actually have no idea. I must have watched a YouTube video or something and saw that a while back. We're almost done. We have 2 questions left. Number 7. This is a weird graph. I do remember this one though. One from 0 to 2. E to the negative t looks like this. It goes down this way, right? And it approaches 0. This one's a little weird to think about for part B. So the first method, we start at 1. Oh, first of all. No, yeah, we're good. This is part A. Why did I just erase that? We start at 1. We go down, and then at 2, we want to go, we're jumping down to 0, right? We're going to 0. So you have to go, so how do you get to 0 from here? You're going to go down, along this section, you're going to go down 1. So you start at here, you're looking at 2. It starts at e to the minus t minus 2. You have to go down 1. So you got to think about it like this. You subtract 1 from it, and it's u to the 2 of t. That kind of makes sense. I don't know if I explained that well. But kind of makes sense because it's a weird graph, right? It's not a straight line. It's a curve, but it's approaching 0. So it's going towards 0. So that's why you subtract 1 from it. But anyways, the second method, f of t, if we look at this, we have 1 of u sub 0, that's 1, plus 1 of, minus, flip the sign, of u sub 2. And then you're going to have, you see how that works? It's just not going to be grouped. And then you have plus e to the minus t minus 2. So it's a good way to check your answer, honestly, if you wanted to. Of u of 2. Of t, I'm gonna write those t's there. Right? It's the same thing. If you pull out the u of 2, you get that. It's the same thing, right? This is the last one I'm gonna do. The next video we're gonna look at continuing this by now taking the Laplace transformation of this f of t, and it's gonna require a new thing from our Laplace table, or a new memorization technique. Okay, so I'll see you then.